Next is the another problem. Here you have to find out this is the problem on the loss due to the shrinkage of the concrete. In this, the concrete beam of the pre-stress by a cable carrying an initial pre-stressing force of 300 kilonewton. And they are given the initial pre-stress of a 300 kilonewton. The cross section area of the wires in the cable is 300 mm square, and calculate the percentage loss of the stresses in the cable only due to the shrinkage of the concrete using IS 1343 recommendation, using assuming the beam to be pre-tensioning and post-tensioning, assuming the Young's modulus of the steel is 210 kilonewton per mm square, age of the concrete at the transfer is 8 days. So they have asked to determine the loss of the stresses due to the shrinkage. This is what you have to be determined. So first you have to find out the loss of the stresses. So loss of the stresses for due to the shrinking is equal to the sigma cs into es. Sigma cs is the residual stresses, total residual shrinkage strain. So residual shrinkage strain which they only have given, so that is 300 into 10 to the power of minus 6. So according to the IS 1343, you have to take it residual shrinkage strain. For the pre-tensioning, it is 300 into 10 to the power of minus 6, and for a post-tensioning you have to take it 200 into 10 to the power of 6, which I elaborated in the theory class in the explaining about the losses due to the shrinkage. You can refer in that theory. You can take that value. So please take note down the total residual shrinkage strain for the pre-tensioning. It is 300 into 10 to the power of minus 6, and for a post-tensioning it is 300 into 10 to the power of minus 6. Okay, so they have given the initial pre-stressing force 300 kilonewton. They are given the area of the cables, that is a 300 into mm square. They are given the Young's modulus of the steel as 210 kilonewton per mm square. So this is what they have given. So first what you have to do is you have to find out the initial stresses. So initial stress, you have to find it. That initial stress is nothing but the load by area. Load, it is given as 300 kilonewton, which is, you can see that 300 into kilonewton, convert that into newton. 300 into 10 to the power of minus 10 to the power of 3, you will get it, divided by area of the cables they are given as 300, which you can see here. Area of the three cables they are given, that as a 300, you take it and find out that one as, and then find out the initial stresses. So initial stresses 300 into 10 to the power of 3, 300 get cancelled, you get 1000 newton per mm square. So this is what the initial stress you have to find out. After finding the initial stresses, later what you have to do is, then you have to find there is a two cases they are given. One is pre-tensioning and another is a post-tensioning. Go for the first pre-tensioning case. For you see here, first one is the I'm determining for the pre-tensioning case. The total residual shrinkage strain for the pre-tensioning is 300 into 10 to the power of minus 6 units. Okay, so loss of the pre-stress will be loss of the pre-stress is equal to sigma cs into es. Sigma cs is the residual shrinkage strain, that is 300 into 10 to the power of minus 6. You can take that. Es, which it is given in the question, that is 210 into 10. You can see in the question it is 210 into 210 kilonewton per mm square. Okay, so that one you have to convert that into newton per mm square. So finally es will be 210 into 10 to the power of 3 newton per mm square. So put that 200 into 10 to the power of 10 to the power of 3 in the place of es. So loss of the stresses is equal to sigma into sigma cs, that is the residual shrinkage strain. So C into es. So es value is 210 into 10 to the power of 3. So totally the loss of the strain you will get it, loss of the stresses you will get it 63 newton per mm square. Now you have to determine the pre-stress loss, percentage of the loss in the stresses. So you got loss of the stresses is 63, but initial stress in the previous you have calculated that one as 1000 newton per mm square. So 63 divided by 1000 into 100. If you do it, you will get the percentage of the loss. You already know the loss. Initial stress is the 1000 Newton per mm square, but the loss of the stress is 63. So what is the difference you will get? So that the percentage of the loss will be 63 divided by 1000 into 100, that which I shown here. See here, so 63 divided by 1000 into 10 to power into 100. If you do it 6.3 percentage, you will get it. The same way, this is which is I have done for the uh, pre-tensioning case. Next, second case we'll do for the post-tensioning case. If the beam is post-tensioning, the total residual strain will be 200 into 10 to power of minus 6. So how you will get it means that by you take that equation 200 into 10 to power minus 6, 10 to power of log 10 8 plus 2. Okay, because 8 t plus 2, that is equation, but in the place of t, you they're given the age of the concrete for at the transfer is 8 days they have given. So t you have to take it as 8 days. So if you do the calculation, you get 200 into 10 to power of minus 6. That is for the post tensioning case. Okay, so after calculating the residual shrinkage strain, then you calculate the loss of the strain. Loss of the strain is equal to, you can see here, I have written in the orange color, that is EC into ES. Okay, so, sorry, sigma CS into ES. Sigma CS is the residual shrinkage which you have calculated that as in the previous step, that is 200 into 10 to the power of minus 6, and ES is the Young's modulus of the steel which is given in the question, that is 210 into 10 to the power of 3. So totally the loss of the stresses is 42 Newton per mm square. So now the percentage of the loss of the stresses is equal to the loss of the stresses and divided by the initial stresses. The initial stress is 1000. You have determined the loss of the stress. What is the loss of the stress? That is 42. That divided by 1000, which you can see in the previous initial stress in the first very step. Initial stress of the wires in initial stress in the wires is 1000 Newton per mm square. Use that value. So now previously you have determined the loss of the stresses, that as in the case of the post tensioning, that is 42 Newton per mm square. 42 divided by 1000 into 100. If you do it, you will get the 4.2 percentage. So finally, the percentage of the loss of the stresses in the case of the post tensioning for the tendons, it is 4.2% in the case of the post tensioning, and in the case of the pre tensioning, it is 6.3, which you have been calculated earlier.